Okay, so in this lesson, we're going to learn how to dilute a solution. But before we do that, let's take a quick look at the warm-up. How many grams do we need to make a standard 100 ml solution of 0.50 molar sodium chloride? Now, a couple of different ways you can do it. If you use that handy formula, grams equals molar mass times molarity times volume in liters, you can calculate it very quickly. And it turns out that the grams is 2.922 grams of sodium chloride. So, making dilutions of solutions. Here's our key formula. M1V1 equals M2V2. So what do the things mean? Well, 1 means initial, 2 means final. M means molarity. So M1V1 is our initial molarity, V is volume, so that's our initial volume. The second side of the equation is the second molarity and the second volume. Key thing about using this equation is the units of volume must be the same on both sides of the equal sign. That's very important. If you have liters on one side and milliliters on the other, it won't work. You can have liters on both sides or milliliters on both sides. You can even have cubic centimeters on both sides. As long as the units agree, the calculation will be valid. So what happens in dilution? Well, let's start by just looking at a beaker that has 8 moles dissolved. Really, it's dissolved in 1 liter. And each mole is represented by an orange ball. So you can see we're going to call it solution 1. The volume is 1 liter. Since there's 8 moles in 1 liter, it is an 8 molar solution. Now, let's add a liter of water to the beaker. So how much do we have now? We have 1 plus 1, which is 2 liters. But did we remove any of the solute? There's still 8 orange balls in there. There's still 8 moles. It's just now, instead of it being in 1 liter, it's in 2 liters. So the key thing here is that when we're diluting, we don't lose any of the moles of solute. Whatever we started with, we end with. But we can have a lower concentration and a larger volume. So you notice that we still have 8 moles of solute, but our concentration is now 4 molar, and our volume is now 2 liters instead of 1 liter. Now you can see the amount of solute, if it's colored, using compounds like copper 2 sulfate. What happens when we dilute copper 2 sulfate with water? Well, it starts out, here you can see in B, kind of a dark color. They added some copper 2 sulfate, added some water, filled it up to 500 mils, and it became a much lighter color. So B compared to C. So if you have a colored solution, it's really easy to see what happens when it's diluted. It's got to have a lower concentration and it'll be lighter in color. Now we can start doing some calculations using that M1V1 equals M2V2 formula. So here's an easy problem. Professor asked his student to make 250 mils of a 0.01 molar solution of sodium chloride. The student has a 5.5 molar standard solution of sodium chloride sitting in the lab, and he's got all sorts of glassware and water so he can prepare the correct amount of the final solution. We're going to use M1V1 equals M2V2, but we have to assign values to each variable, and we also have to identify what we're solving for. The second molarity is the molarity of the final solution, which is 0.0100 molar. The final volume we're trying to make is 250 milliliters. The initial molarity is the molarity of the standard solution, 5.50 molar. And finally, we're trying to determine how much of that we need to add and dilute in order to actually make this solution. So we're trying to find V1. Now, since V2 has the units of milliliters, V1 in this answer will also have the units of milliliters. So then we just plug in everything and solve. Okay, so M1 is here, times V1 equals M2 times V2. So you can see we're gonna have to divide both sides by 5.50 molar to solve for V2. So when we divide both sides by that, it drops out, so V2 is alone. And on the other side, you end up with 0.455 milliliters of that 5.5 molar standard solution of sodium chloride. So that's how much of that solution we need to add into this final volume of 250 mils to make our 0.01 molar solution of sodium chloride. Now, this is a very straightforward, simple problem. The next one is also straightforward, but you've got to learn how to read the question. It needs to be broken into two parts. So here's a two-step problem. A solution is made by taking 5 grams of copper 2 sulfate and dissolving it in a final volume of 100 mils. That's the first part. Second part, once this standard solution is made, we take 10 mils of this solution, add it to 150 mils of water to make a new solution. So what's the molarity of the new solution? Well, it's 2 steps. We got to find the molarity of the first solution before we can find the molarity of the second. So step 1, find the molarity of the first solution. So we've got 5 grams of copper 2 sulfate and we've got 100 mils. So you can see we're going to take our 5 grams of copper 2 sulfate. This is the molar mass of copper 2 sulfate. We divide, and that'll give us moles of copper 2 sulfate. And then we divide that by the volume in liters. So it's 0.100 liters. This number of moles divided by that volume gives us this concentration, 0.313 molar. That's our standard solution that we made in this first part. The first part is just the first sentence. Okay, now we're going to need that in the second part, because look, we're going to take some of that, 10 mils of this, and we're going to add it to 150 mils of water, and then we're going to have to determine what the molarity is. So, step 2, we're going to use M1V1 equals M2V2 to find that final molarity. M1 comes from step 1. We found that the first solution was 0.313 molar. The volume comes from the problem. It was 10 mils. We're going to take 10 mils of this, 10 mils of the 0.313 molar. Now we're going to calculate what M2 is. That's what we're trying to find from the problem. V2 is the only one that's a little tricky, because what it said was we're going to take 10 mils and we're going to add it to 150 mils to make our final volume. Our final volume is 160. It's not 150, it's not 10, it's 160. It's the sum of the two because we added 10 to 150. Now, once we solve for M2, we end up with molarity 1 times volume 1 divided by volume 2, and then we get our final answer. Our molarity of that second solution is 0.0196 molar. Okay, now off to working on the worksheet.